All right, so this is 8.2 in Math 9, and you can turn in your textbook there. If you want to 8.2, Pearson Math Makes Sense, it's on page 392. So you can turn there and take a look at some extra diagrams and some other things that you can look at while we move through these notes. So I'm going to have the theorems, the important theorems here in your notes, but there are going to be other examples and diagrams in your textbook that you'll want to look at as well. So let's get started. What is the goal of 8.2? Well, we're talking about chords in a circle. I'm a musician, so I like to play chords, piano chords, guitar chords, different than these kind of chords, right? Chords in a circle, we're going to find out it's a section, a segment of a line that goes from one part of the circle to the other part of the circle. And there's all sorts of theorems, that is sort of rules or laws that follow chords. So we're going to explore those today. So let's get started. So the focus is to relate a chord, its perpendicular bisector, and the center of the chord, and then solve some problems. So there's a few things here that maybe you haven't heard of before. A chord as it relates to a circle. Perpendicular, you should know what perpendicular means. Does anyone know what perpendicular means? Just want to shout it out. I think you're.
They'll never intersect.
Okay, I think you're thinking parallel. Yeah, that's parallel. Two lines that will never intersect are parallel. So what's perpendicular?
It means there is a 90-degree angle.
Right. At their intersection point, they make a 90-degree angle. That is, two lines or two segments would be perpendicular if there's a 90 degrees. So if they're kind of off like this, that's not perpendicular, but boom, perpendicular. All right. Does anyone know what bisecting means, or what a bisector would be?
Something that's divided into two.
Okay, very good, very good. So that's exactly what you do to a word that you've never seen before. You break it down. The first part of the word is bi, that means two. Sector would be sections, right? So two sections. That's very good. Obviously, we know what the center of the circle is, and so let's get going here. All right. Any circle whose center is O, and we have that in the diagram right here, and a chord AB. Okay, so let's take a look at what the chord is. So the chord is, as I mentioned before, it's a segment, and we have this in our definitions from last section, I guess, but it's a segment of a line that goes from one point on the circle to another point on the circle. Okay, it stretches across the distance in between the circle there to another point on the other, somewhere on the other side of the circle or around the bend there. So that's a chord AB. So if OC bisects AB, so bisects means, we said splits it in two, and more than just splitting it in two, it actually splits it into two equal halves. That's technically what bisecting means, splitting it right in half into two equal sections. Okay, and here it is right here. Bisector means it's divided into two equal parts, and I think you have a blank to fill out there. So perpendicular's up on the board here now too. So perpendicular means that at the intersection of a line and another line, or a segment and another segment, there is a 90-degree angle. Okay, so you can fill that out in your notes. So OC, that is a segment O from the center to this point C. If that bisects AB, then OC and chord AB are perpendicular, and this is the notation for being perpendicular. It's like an upside down T. So two segments or lines, if they have the upside down T in between them, that means they are perpendicular. They form a 90 degree. Okay? So also, if OC is perpendicular to AB, that means that this is exactly split in half, or AC, that's this segment, is exactly equal to CB, this segment. So there's there are a few related truth statements here. The perpendicular bisector of AB goes through the center O. So if we had just a chord, and I say I'm going to draw a line that is 90 degrees through this chord AB, and it's right in the middle, and it forms a 90 degrees, then guess what? That line is eventually going to go through the center. So it's kind of like looking at this situation from a lot of different angles, right? From the perspective of the chord, from the perspective of the center, from the perspective of the 90-degree angle. So all these things fit together, okay? So we're going to use this information and other bits of information to solve problems. Now, I do have this over on the side here. I have a circle on the right side, and I have a little radius, okay? And I want to just animate this just a little bit. So I'm going to highlight this radius, and if I draw a radius that goes from the center to the edge of the circle, and two things. If this side of the chord that is cut and this side are not equal, what else is not true about this situation? Name me one thing that as well is not true compared to what we just learned. Yeah? Okay, good. This radius and this chord are not perpendicular. Very good. So that means that this angle is not 90, nor is this angle 90. Excellent. That's exactly what I want you to think about. So how could I ensure, whoops, I'm trying to erase this, just the parts I want to erase. So how do you think I could ensure that these two, come on now, just there we go. How do you think I could ensure that these two segments of the chord are equal? What should I consider doing with this radius? So I want this part of the chord and this part of the chord to be equal. What do I need to do? I need to make sure that what happens?
90 degrees.
Yes, that there's a 90-degree angle between the radius and the chord. Right? Then I know that they will be equal. Okay? And hopefully you see that. Hopefully you see as I move this radius around. See if I can grab it again. So if I move this radius around, you see how the sections, obviously we don't have a 90 and the sections aren't equal. Okay, there we go, pretty much 90 right there. Sections are equal, each side of the radius. Okay? Okay, any questions about this first part? Any questions at all about this first part? Anything that doesn't quite make sense to you? So that's what you got to fill in, and this is what you have to fill in for your notes there. Okay, let's keep going then. All right, so example 1, O is the center of the circle. Find the length of the chord AB. Now, we did a little bit of this in a worksheet already, right? We know about this kind of question already, so you guys should know how to do this because we already looked ahead to this one through the worksheets and the different things we've talked about. So, O is the center. Sorry, what else does it say? Find the length of chord AB. O is the center of the circle. So I guess we're also going to assume that, doesn't say in here, but we're going to assume that this is a 90-degree angle as well, which that should be written in there as well, I guess. That's a 90-degree. So if this is a 90-degree angle, we have the right triangle going on, right? We have a hypotenuse, we have a length, and we could actually find this side right here, CB. So let's set that up. 6 squared is one of the legs of the right triangle plus, and I'm just going to write this section as CB, so CB squared equals the hypotenuse squared. I'll solve for CB, so let's do 10 squared minus 6 squared. So this is 100 minus 36. CB squared is, what's 100 minus 36? 64. The square root of both sides to get CB, just that length by itself, and I get 8. All right, so that means that this side is 8. Okay, Pythagoras, but we're using Pythagorean theorem. So the question says find the length of chord AB. So AB is going to be double the value that we found over here. So it's going to be 8 times 2. So AB is 16 centimeters because centimeters are the units given in the question. Okay, how are you guys feeling about that? That's 8 times 2. Good? All right. We've already done some questions like that, so this should be just a, yeah, that should be pretty easy. Okay, so here's a question, number 2. The diameter of a circle is 18. A chord JK is 5 centimeters from the center. Find the length of the chord JK. So they've actually given a little bit of help to you. You have this in your notes, right? It's not colored for you, but 18 would be the diameter. That means that the radius is half of 18, or 9. And that radius can swing anywhere around the circle, right? Including from the center to the point, that is the point K. So you can always use the diameter to solve a question like this. Let me put it another way. Okay, so you could solve a question like this that has a diameter and any other chord like this, if you know what this length is and you know what that diameter is, you see? So that's kind of what this question looked like without the little red parts that helped you start. So if you have something like this, you could actually say, okay, I know that this is a radius, that also this is a radius. So there you go, you've made your little right triangle, Pythagoras works, and you also know if that's 90, that these two sides are the same, like these two lengths. Okay, I hope you're getting that. Let's finish this question. So I'm going to have 5 squared plus, let's make this, I don't know, what is it? Let's just make this x here, I guess. This little half, x squared equals, the radius was 9, so 9 squared. X squared equals, we're going to subtract 5 squared from both sides. And you can actually evaluate these if you want. 9 squared is 81. 5 squared is 25. Okay. So x squared equals, what's 81 minus 25? 56. Okay. Take the square root of both sides. 56 is not a perfect square, is it? So we're going to have a decimal, looks like here.
7.4833147.
Okay, so 7.48 something, right? Something like that? Okay.
Yeah.
So that's the x part, and of course we're trying to find jk, so we do 2x, right, is 2 times the 7.48 decimal there, which is going to equal 14.967, something like that. And the units are centimeters. So that's what jk equals. Are you guys okay with that? It's okay if you round it up. What do you mean? If you yeah, you don't have to have 3 decimal places. You could have 1 decimal place is fine. Usually I suggest going to at least 2 if you're wondering. But if the question says round to the nearest 10th, that's 1 decimal place. To the nearest 100th, that's 2 decimal places. If it doesn't say, I think you should round to at least 2 decimal places. So yeah. Yeah. So 14.97 would be fine as well. 15.0 would be rounding to 1 decimal place. Okay. How are we doing? Feeling good about this? Good. I feel like with our work on the worksheets and the couple days that we've already spent, you guys are already quite prepped for this. So this is great. A chord MN, this is example 3, and actually I'm going to let you guys tackle example 3 on your own. Okay, so take a moment, take a look at example 3. It says a chord MN is 24 centimeters. So there's, chord MN. Okay, MN, so this length is 24 centimeters, which means that M to this point right here is 12. You see that? They've got that filled out. The radius of the circle is 20. Find the length of x. Okay? Now this is a bit of a different question. So I want you to try this one on your own and see if you can solve for x. This might be challenging for some of you, but take a couple minutes and try and solve for x on your own. Please show your work, and then we'll go through this question in a couple minutes together. All right, so let's take a look at this together. As I mentioned here just a moment ago, that the key here is to find this little right triangle, right? And we have 2 sides of this right triangle. That's great. I can find the 3rd side. Let's call that A. Now, why is that important? Well, I want you to look ahead and I want you to notice this, that A plus this length x is equal to what?
20.
Very good. A plus x is equal to 20. Why? Because this is a radius. That's a radius of the circle. So we can find out what x is because I know what the radius is. I just need to find out what this other piece is, then I can solve for x. So we're going to find a by doing 12 squared plus a squared equals 20 squared. Pythagoras. A squared equals 20 squared is 400. 12 squared is 144. So a squared equals, what's this going to be? 256. Square root both sides. A equals 16. You guys get that? So that means that a is 16. So 16 plus x equals 20. X is 4. 4 what? 4 centimeters. Okay, so that is a complete 10 out of 10 question right there. Show your work, circle your answer, have your units. Make sure that you communicate what you're doing on the steps. Any questions? Okay, before I did that question for you, how many of you got 4 as an answer? Okay, a good chunk of you, that's great. Okay, example 4. Okay, example 4, find angle measurements of x, y, and z. So these are just angle measurements, and again, what we have are triangles. So we know that all the angles of a triangle add up to 180. And notice this, you can't assume that this is a 90-degree angle, but when you see that this part of the chord AC and this part of the chord CB, if those are equal, then guess what? We can now know that x is 90. So x, I'll use a different color there. So x is going to be 90 degrees, okay? Because that chord is bisected. And this side goes through the center. So you have the bisection, and you have this side going through the center, therefore x has to be 90. All right, well, what about y? Well, if you do 180 minus 30 minus 90, that's going to give you y. So 180 minus 90 is 90, minus 30 is 60. Very good. So we have x equals 90, y equals 60. And now let's take a look at z. Okay, there's 2 ways you can look at z. Okay, this is 90 right here. We know that. This is, the thing you want to notice is that these triangles here, this radius is the same on both sides, right? This side is the same on both sides. And this side right here is just equal to itself. So we have 2 identical triangles here. All the sides are the exact same length. You see that? So really, all of the angles that are corresponding are all equal. So this 30 degrees has to be what z is. Another way to look at this is that this is an isosceles triangle because we have r and r. So that's an isosceles triangle, which means that this angle opposite of r has to be the same as this angle that's opposite of r. So z is 30 degrees. Okay. Questions there? Whoops. No questions? Yeah, no? Okay, I'm going to give you a few minutes. How many do we have here? Just these 2? Okay, I'm going to give you a few minutes to do these on your own, please. I want to see everyone have an attempt at this. So I'm going to give you some time to work on this. When you're done, you can either put your hand up and show me that you're done, and I'll come check your work. Or I'll go through these quickly together in about 3 or 4 minutes here. Okay, so go ahead and work on those. Make sure that they're done. You've shown all your work. All right, let's take a look at these questions here. Pretty straightforward with the angle measures. Okay, because that AC and CB are equal, that means that this side going through the center must perpendicularly bisect that angle. So x is 90. Okay, it's perpendicular. And then we know that all the angles of a triangle must add up to 80, 180. So 180 minus 40 minus 90, because 40 is given, equals 50. So did you get 50 for y and 90 for x for that one? Okay, good, good. All right, next one over here. By the same logic here, because AC is the same as CB, that means that this side going through the center must form a 90 degree there, so X is 90. Also, we have 180 minus 55 minus 90 equals Y, and Y is 35. Remember that this is an isosceles triangle because this is a radius and this is a radius, so opposite angles that are opposite identical sides in an isosceles triangle have to be equal, so Z is 55. Any questions about that? Anything about that that's unclear? Or
You have to state that it's like an isosceles.
yes, you should state your reasons for why things are the way they are as best you can. Yeah, this is actually it's where students kind of, I find that like explaining or justifying your decisions. I know that most of you would be able to look at this question and probably do most of this in your head, right? If you couldn't do it in your head, you could punch it up on the calculator. You get these numbers pretty quick. I know that. I'm not too concerned about that because I think all of you are pretty bright, and you can all do that. The tough part is articulating, which is a word that means, kind of explaining, verbalizing, describing how you're doing the math, how your thoughts are coming together to give you the answer. That is the toughest part of math. And so when the book says justify, I know we kind of gloss over that. Give your reasons, right? That turns into showing my work actually is not important either, which is super important. So I kind of want to help you justify, help you give your reasons. So I know that you're probably thinking a lot of this stuff, right? Because you just learned it. So how can we articulate this? How can we actually put our thinking onto paper? Very important skill. So please try and do that. All right, do it as best you can. But this is tricky. I know in grade 9 especially. But yeah, try and do that. Okay, if you can do something like I just did here, give a little bit of reasoning as to why you gave your answers. This is infinitely more valuable than just the numbers themselves. And infinitely is maybe a bit of an overstatement, obviously. But it's quite a bit more value if you can actually, describe a little bit why you're getting your answers. That's very important. Okay, here's your assignment from the text. Please write this down. It's 8.2, page 396. In your Pearson Math Makes Sense textbook right here. And that says 3 to 7, 10, 11, 17, and 19 is a take it further question. Technically, it's optional. I want you all to try it because I think that all of you can take it further. So I want you all to try it. But I do put optional. I don't know why I do that. I shouldn't put optional, but you all need to attempt that. Okay. Any questions?
Wait, what's up? Is it 20?
Sorry?
Is it 20 optional or
19.
19?
19.
I don't know. I didn't know what it was. I look up there.
Yeah. You can do more questions if you want.
Oh, no, I see. It's an O and a.
OPT. That's OPT. Sorry, OPT. Okay, that's not a long assignment, so I don't think you'll have trouble with it, but get started on it now. You actually have a good chunk of this class to work on that. I think the plan is to let you finish this tomorrow during some class time. Can't guarantee the whole period, but try and get as much of this done as you can here today. So any questions?